Hello students, welcome back to my 6th lecture on basic maths. In our lower classes, we have studied how to solve the system of linear equations or pair of linear equations using various methods such as substitution method, elimination method and cross multiplication method. So now we are going to study how to solve this pair of linear equations or system of linear equations using determinants, and this method can be done by Cramer's rule or the determinant method. Okay, let's see how to solve the system of linear equations using Cramer's rule. Consider the equations a1x plus b1y plus c1z is equals to d1, a2x plus b2y plus c2z is equals to d2, a3x plus b3y plus c3z is equals to d3. Now I will take first step as delta, which is equals to the coefficient of x has to be taken as the first column, and second column 2 will be the coefficient of y, and column 3 will be the coefficient of z. We get a1, a2, a3 as first column, b1, b2, b3 as the second column, c1, c2, c3 as the third column. Now multiply x to the first column. You get delta x is equals to a1x, a2x, a3x. Second and third column, leave it as it is. Let it to be as it is. And now column 1 changes to sum of column 1 plus column 2 multiplied by y to column 3 multiplied by z, and add all the three columns. You get delta x is equals to a1x plus b1 into y plus c1 into z, a2x plus b2y plus c2z, a3x plus b3y plus c3z as a first column, and second and third column will remain as it is. Now we know that a1x plus b1y plus c1z is nothing but the constant delta 1. Similarly, a2x plus b2y plus c3z is equals to c2z is equals to d2, and a3x plus b3y plus c3z is equals to d3. Substitute or replace the first column as d1, d2, d3. So after calculating the determinant, you get some value. Let it to be delta 1, you can say. Similarly, we can find the value of delta y, just replacing the value of the second column as d1, d2, d3. Keep first column and third column as it is. You get some value. Take it as, that is, say delta 2. Similarly, for the third column, if you replace it by the constant term d1, d2, d3, you get the value of delta z as d3, delta 3. We get the value of x on dividing delta 1 by delta. Y value will be delta 2 by delta, and z value is equals to delta 3 by delta. So this is known as Cramer's rule in honor of the Swiss mathematician G. Cramer. Let's see how to solve the system of linear equations using Cramer's rule by taking an example. Two equations over here. They are 3x plus 4y is equals to 7. 7x minus y is equals to 6. First step is writing the delta, as the first column will be the coefficient of x, 3, 7. Second column will be the coefficient of y, that is 4 minus 1. Now solve for delta, that is equals to 3 into minus 1 is minus 3 minus 7 into 4 is 28. After solving this, sum of 28 and minus 3, minus 28 minus 3 is minus 31. Similarly, delta 1 is equals to, change the first column as the constants. Keep second column as it is. Now find the value of the determinant. You get 7 ones are minus 7. 6 into 4 is minus 24, which is equals to minus 31. And delta 2 will be equal to, keep first column of delta as it is, change the second column as a constant terms. Now solve for this. 3 into 6 is 18. 7 into 7 is 49. After subtracting, you get minus 31. Find the value of x and y on dividing delta 1 by delta and delta 2 by delta, which is equals to, delta 1 is minus 31. Minus 31 upon delta value here is minus 31. Divide minus 31 by minus 31, you get 1. And value of y is equals to delta 2 upon delta, which is equals to minus 31 upon minus 31, which is equals to 1 again. So here the values of x and y are 1 and 1. To verify whether we got the correct answer, you substitute these two values in the first equation or second equation. So I will substitute the value of x in the first equation, that is 3 into 1 is 3, and y value in the first equation plus 4 into 1, that is 3 plus 4 is 7, which is equals to our RHS. That means we got the correct answer. So similarly, can you try for the second example? Solve by using Cramer's rule. The equations here they are given as 5x minus 7y minus 3, which is equals to 0. 7x minus 5y minus 9 is equals to 0. So you shift 3, minus 3 and minus 9 as constant to the RHS side, so that we get the delta 1 and delta 2. Okay, I hope you will try this. Next example number 3, solve by using Cramer's rule. X plus y plus z is equals to 7. 2x plus 3y plus 2z is equals to 17. 4x plus 9y plus z is equals to 37. Now the first immediate step is writing the delta as the coefficient of x in the first column, coefficient of y in the second column, coefficient of z in the third column. So that will be, after calculating, you get the value that is equals to minus 3. With row wise I am calculating, taking 1 into, leave the same row and column and multiply the remaining 4 elements. That is 3 into 1 is 3 minus 9 to the 18 minus 1 second column. Leave the first row and second column. The 4 elements multiplication will be 2 ones are 2 minus 4 twos are 8 plus last one 1 into, leave the first row and the third column. You get 2 into 9 is 18 minus 4 threes are 12. Simplify this line. 3 minus 18 is equals to minus 15 minus 2 into minus 8 is minus 6. You get minus 15 plus 6 plus 6, that is 18 minus 12 is 6. After solving this, you get delta value is equals to minus 3. Similarly, To get the value of delta 1, replace first column as the constant terms, that is 7, 17, 37 in the first column. Keep second and third column as it is. Similar way you have to expand it first row wise. You get delta 1 is equals to minus 6 and delta 2 value is equals to, replace second column as a constant, first and third column keep it as it is, and after expanding you get the second delta 2 value is equals to minus 9 and delta 3 is equals to, keep first column second column as it is, replace third column as the constants. After calculating delta 3, that is determinant, you get the value that is equals to minus 6 and find x value, that is equals to delta 1 upon delta. The value of delta 1 here is minus 6 upon delta value is minus 3. Divide these two numbers, minus minus will get cancelled, 3 ones are 3, 3 twos are 6. X value is 2 and y is equals to delta 2 upon delta. Delta 2 value is minus 9 upon minus 3 is equals to, 3 ones are 3, 3 threes are 9. Value of y here is 3 and z value is equals to, divide delta 3 by delta. The value of delta 3 is minus 6 upon minus 3, which is equals to 3 twos are 6, that is your value of z. Now substitute the value of x, y and z in the equation for verification. X plus y plus z, that is 2 plus 3 is 5, 5 plus 2 is 7, which is the required answer, RHS answer. That means our values of x, y and z here are correct. Next simple example for practice purpose from the exercise. Solve by Cramer's rule. The two equations here are x plus y is equals to 7, 2x plus y is equals to 8. Now write the delta, that is the first column becomes the coefficient of x and second column will be the coefficient of y. After solving the delta, you get the value of delta is equals to minus 1 and delta 1 is equals to, replace the first column as the constant terms, that is 7 and 8 are constant here. Write the second column as it is and solve for the determinant, you get it as minus 1 and delta 2 is equals to, replace second column as the constants and solve for the determinant, you get delta 2 is equals to minus 6. Now to find the value of x, divide delta 1 by delta, that is minus 1 upon minus 1, which is equals to 1 and value of y is equals to, divide delta 2 by delta, you get 6. Next example, 4x plus y is equals to 7, 3x plus 4z is equals to 5, 3z plus 5x is equals to 2. Rewriting the above equations, we get 4 into x plus y. There is no z given, so multiply it by 0 into z, that is equals to 7. And second equation will be 0 into x plus 3 into y plus 4 into z is equals to 5. Third equation will be 5 into x plus 0 into y plus 3 into z, which is equals to 2. Now write down the first determinant, that is delta, which is equals to, the coefficient of x is in the first column 405, coefficient of y in the second column, that is 130, coefficient of third coefficient of z in the third column, that is 0, 4, 3. Solve the determinant, you get the value, that is 56. Similarly, delta 1 will be, first column change it as the constant, replace it, and let it be second and third column as it is, and find the solution for this determinant. You get it as 56. And delta 2 is equals to, keep first column as it is, third column as it is, replace second column as the constants, and solve the determinant. You get delta 2 is equals to 168. And delta 3 will be, third column will change as the constants. First column, second column will remain as it is. After solving this determinant, you get it as minus 56. So now divide delta 1 by delta to get the value of x. That is equals to, delta 1 here is 56 and delta here is 56. So when you divide 56 by 56, you get 1. And y is equals to delta 2 upon delta, which is equals to, delta 2 value here is 168. 168 upon 56, which is equals to 3. And z value is equals to delta 3 upon delta, that is equals to minus 56 upon 56, which is equals to minus 1. So now next example with 3 rows, 3 columns, that is 2x plus 5y plus z is equals to minus 1, x plus 7y minus 6z is equals to minus 18, y plus 2z which is equals to 3. Multiply 0 to x and rewrite the third equation only. 0 into x plus y plus 2z which is equals to 3 is your next third equation. Now first step is writing the determinant. That is, first column will be the coefficient of x, that is 2, 1, 0. Second column will be the coefficient of y, that is 5, 1, 5, 7, 1. And coefficient of z is your third column, that is 1, minus x, 2, which is equals to, first row wise expansion will be 2 into, leave the first row and first column and multiply the remaining 4 elements. You get 7 into 2 is 14, 6 minus 6 into 1 is plus 6, that is 2 into 14 plus 6, minus 5 into, leave the first row and second column and multiply the 4 elements. You get 1 into 2 is 2, minus, here minus 6 into 0 is 0, plus 1 into first row and last column you have to delete and multiply the remaining elements. You get 1 into 1 is 1, minus 7 into 0 is 0. After simplification this step, you get the value of delta is equals to 31. Similarly, try for delta 1. Change the first column as the coefficients, constants, sorry. First column you replace it by the constant terms. Keep second and third column as it is. And solve the determinant. You get the value of delta 1 is equals to 31. And delta 2 values you will get if you replace second column as the constants. First column, second column keep as it is. And solve for the determinant. You get delta 2 is equals to minus 31. And delta 3 is equals to change the third column and keep first and second column as it is and solve the determinant, you get the value of delta 3 is equals to 62. Now find x, y and z values. On dividing delta 1 by delta, which is equals to 31 upon 31, that is value is 1, x value is 1. And y you get, if you divide delta 2 by delta, that is equals to minus 31 upon 31, which is equals to minus 1. And z value is equals to delta 2 by delta, delta 3 by delta, that is equals to 62 by 31, that is equals to 2. Verify by substituting the value of x, y and z in the first equation or second equation or third equation, any equations of the given 3 linear equation for verification. Now the exercise 1.5, in the first main part, solve the following by Cramer's rule. Here the value of x and y you have to find the first 4 equations, and in the second part you have to solve the value of x, y and z. Some I have solved, we have discussed now only. So remaining, I hope you will try this by writing and also by verifying the values of x and y. With this I will conclude. We will meet with a new concept in the next class. Thank you.